Hi, I'm Rainer, and this week we're going to be talking about a problem involving forces, impulses, and times. So in this problem, we're given a mass of mass m naught, and we're told that this mass is acted on by a force with a function at plus b. So this is a function of t where a and b are constants. And we're told that at the initial time where this force starts acting, this has a speed of v1, and at the final time it's got a speed of v2. So our question is, how long does this force act on the object? And so I need to find a way to relate force as a function of time with speeds and masses. And the first thing that comes to my mind is the impulse momentum theorem. Because I know that I can use the forces and the times to get an impulse, and I can use the masses and the velocities to get a momentum. And this could be really useful. So let's go ahead and say, let's look at a system of the mass, m naught. And we'll say that we'll just need to apply the impulse momentum theorem. So I'll say impulse equals delta p. Since this is all in one dimension, I won't care about vectors or anything like that. So with that in mind, we'll say impulse, I know how to get that. That's the integral of force with respect to time. So I'm going to say impulse is integral of f dt, and I'll plug in some bounds later. But in general, it's just the integral of force with respect to time. So with that in mind, I want to choose a time interval that goes across from the time where it has v1 in speed to the time where it has v2 in speed. And so I'm just going to call it delta t, and I'm going to start my clock at 0 and go to a time of delta t. So I'm going to say integral from 0 to delta t of this force. So at plus b dt. Now if I take this integral, I'm going to get something like a t squared over 2. And I'm going to go ahead and plug in, no, I won't yet. I'm going to get at squared over 2 plus bt. And I'll apply the bounds from 0 to delta t. And then if I plug in again, I'll get a over 2 times delta t squared plus b times delta t. So that right there is my impulse. And with that in mind, we can set that equal to change in momentum. Well, I know that change in momentum is just mv final minus mv initial, because mv is the definition of momentum. So v final is v2, v initial is v1, and there's my delta p. So with that in mind, I'll come down and I'll attach it down here. Say impulse right here equals I'm sorry, I called this m naught. We'll call it m naught, not m. M naught v2 minus v1. And this right here, we can solve for delta t. And I won't do that. It's a quadratic equation. Take a long, pointless derivation right here. But if we solve this for delta t, we get the amount of time that this force acts on this mass. So that's all we have to do.